which should go green. And, well, do you have a network cable?
Yeah, I might have.
Because network would be even better for streaming. Right, so then I can exit out of that and go to here, turn on my... Right, okay, so, hello everyone. I've got a good crowd here. So what I was asked to do was to talk about LaTeX. And so when you're going to talk about LaTeX, you might as well go the whole hog. So what I've done here is I've written this in the Bema class in LaTeX, so I can show you how I've written this presentation, the tools I'm using to display this presentation, as well as the LaTeX that we do for our thesis documents. I'm Simon McCallum. I've been lecturing here for a long time, and I took over some of the LaTeX template document stuff from Eva, because Eva didn't want to have to deal with it anymore. Our LaTeX template is a bit of a messed up template because initially it was designed around Word, and so it actually doesn't use all the power of LaTeX. But we'll talk you through how LaTeX works, why we use LaTeX, and then some specifics about how to write your bachelor thesis in LaTeX, and some tools. And I only have half an hour, so that's going to be stressful. So I'm using the Bema class to do this presentation. And what we have is that here in NTNU we pay for Share LaTeX. So all of you should use Share LaTeX at least a little bit. It's great for collaboration. It's just also merged with Overleaf, which was the other big online LaTeX tool. So if you go to sharelatex.com, there is a Learn LaTeX in 30 minutes. Now, I had considered whether I should just put up that website and go and sit in the audience and go, see, I'll just let you guys read for 30 minutes while learning LaTeX. Given that that resource already exists, go and do that. You'll learn a lot of the standard bits of how to use LaTeX. So in today's talk, I'm going to go beyond just the standard bits of using LaTeX, some of the justification, and some of the things we do as best practice, which is different to just using LaTeX. So LaTeX is a markup language, right? So the idea, just like HTML, you have text, and then you have symbols and code that tell you about the text, right? So your objective in LaTeX is to write down your thoughts in words, and then tell the computer about those words, right? And then it will work out how to format them, how to make them look pretty, where things should be, how to number things. All of the boring bits of document layout, LaTeX should do for you, right? Now LaTeX is a container style markup language, right? So what it does is it has lots of begin and end environments, right? So it builds these containers. You put your text in here and wrap a container around it, right? So that's the kind of model that LaTeX uses. When you are having to number anything or reference things or decide where things should go, then in the LaTeX case, it's LaTeX that does that decision for you. Okay? And one of the standard things that we have to do with my students every year is I say, oh, but I want that image higher. And I say, no, 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 you don't get to choose that. LaTeX chooses where your images go. Trust the tech, because we have an agreed way of laying things out. Right? If you follow LaTeX layout style, you cannot be wrong. If you edit the style, and if you put things where you think they're good, you could end up being wrong. Right? And so what you do is you say, no, no, all the formatting decisions, those are made by LaTeX. The lecturers have told me the template to use. I write my words, and I tell it this is a figure, place it into my document. LaTeX will decide where that goes. So the job here is not for you to try and lay out your document in a pretty way. It's to tell the compiler, LaTeX, what your document is and the content of that document, and then let LaTeX do the rest. If you are really, really upset with the layout, you come and see us and say, why is this so terrible? Can you fix it? And we either say, no, we wanted it that terrible, right? That's what we thought is good, right? Which means, you know, we have a different opinion and we're marking it, so unfortunately our opinion is consistent with the marking. Or you actually have found something that I should fix, right? And so then we fix things. So you should not have to worry about how to number things and how to cite things. You just cite them and let LaTeX do all of that layout. There's also an interesting feature, and I see this with like PowerPoint. This is not PowerPoint, this is the NTNU template for Bema presentations. So this presentation is also written in LaTeX with speaker notes and is being used as a PDF that is being presented through a PDF system, which also has, you know, time elapsed and clock and all the other things that you get from a nice PowerPoint presentation, but entirely done with LaTeX tools and PDF. So I'm doing this whole thing completely committed 100% to LaTeX. The tool you use influences the way you think. So when you use PowerPoint, because it defaults to text with bullet points, people write slides as text with bullet points because that's what the tool does by default. If you move over to Prezi and you use a visual editing tool, suddenly it's like, oh, images are the default thing to do. Right? So the easiest thing to do in Prezi is put an image in, and putting in text is difficult. And so what people do is they adapt to think in the way the tool makes easy. In LaTeX, you are supposed to stop thinking about how pretty your document is. Let us worry about that later. You should be focused on what you're saying, your words and your thoughts. And so that's what LaTeX is trying to do. It's trying to stop you thinking about prettiness and start you thinking about the context. So some of you, interestingly, in this particular university, will be experts in layout. So how many are doing the masters in with interaction design and typography and layout? So do we have any of them here? Right. So the rest of you probably aren't experts in document layout and kerning and font sizes and font styles and point styles, and this is not what you do as your job, right? So if you don't do it as your job, then you leave LaTeX to do it, right? If you're better than LaTeX, that would be fantastic, but the percentage is like this big, right? So you're tiny. One of the other problems with formatting is we have an NTNU style guide, right? And we have an NTNU style template, which I'll show you. But journals and conferences all have their own styles and their own formatting and their own structure. And if you've ever tried to get Word to change its format, it just takes a long time. You've got to put all the margins in the right places, and then things wrap, and then they go over the page wrong, and it takes hours and hours, days to fix a Word document from one conference style to a different conference style. In LaTeX, the ideal situation is I just change a word and it all just happens, right? Because I say which style I'm using. And if I've written my document in a sort of generic compliant way, then yes, it will just work between lots of different journals and lots of different publishing standards. Most of you are web users and so know about HTML. Hopefully most of you have heard of CSS. Anyone never heard of CSS?
Well, never.
No, that's good. Okay, so the idea is in HTML, you have an HTML page which is your data, and then you have this cascading style sheet thing which shows you how it looks. So that when you view it on your mobile phone, you view it in a different way to on your computer. Right? That's because the data and the presentation have been separated. That's what we're doing. We are separating the LaTeX, which is your data, from the presentation, which is the particular B5 double-sided book format that you have for your master's thesis, or A4 one-sided document that you have for your bachelor thesis. Now, in our LaTeX template, that's a single word you change, and it will change all your layout, all your positioning, all your margins, everything for you. So you can either do the big A4 single PDF thing, or make a booklet format for printing on a B5 book, right? So LaTeX sorts that for us. It also works out our the appendix, the references, your contents page, your indexes. You can automate all of that. And the reason why is that, yes, it is a learning curve at the beginning of doing your masters or doing any project. Yes, it will take you time before you start getting comfortable in LaTeX. But the amount of money I would have to pay you to get you to do 1 hour of work in January versus 1 hour of work in late May, right? Because in early January, you'll do it for a pizza. And you've got 3 hours until you submit. Your time is worth a lot. You don't want someone just coming off your 50 krona and you'll say, oh yeah, I don't need to finish off my thesis, I'll just do that, right? So the value of your time goes up and up and up and up towards submission. So if you can spend time at the beginning to save time at the end, this is a useful investment. Okay, so sharing. So share LaTeX, we want you to use that. It's like Google Docs, but for LaTeX. So, and I can flip over, once I've got these slides along, I'll flip over so I can show you the share LaTeX and me using it. LaTeX is text files, so when you share them with people, you're just sharing text file, which means there aren't anything hidden, there's no formatting, it doesn't matter whether it goes from a Mac to a PC or a Linux machine, it's just text. Right, so it makes sharing much better. It works with all your version control tools nicely, so if you're using GitHub or Bitbucket or any SVN or any version control tool, LaTeX works perfectly with it. There isn't hidden content. I don't know if any of you have done this, but you know, when I was editing Word documents, I'll press delete and suddenly all the formatting in the rest of the document changes. Because I've secretly deleted a formatting thing that I couldn't see, and now everything's changed. And so I have to do undo, and then I have to kind of move up and delete the spaces above it, and move down and delete the spaces after it, and try and go, there's something special there, but I can't see it. Right? That doesn't happen in LaTeX. Right? It's all there. And once you solve the problem, you've solved it, because you've solved the piece of code required. What we recommend you do is you also write in separate documents. Because LaTeX actually has a neat feature, which I'll just talk about, which is including other documents. So you actually can write, instead of having one big LaTeX file, like one big Word file, you just write it in all little individual files and then just include them all when you want to make your big document. Which means if you're working in a group, I can say, oh, you work on that file, I'll work on this file, and you work on that file. We just write our own independent text files, merge them, and it all beautifully merges, and you don't have these kind of, oh, but I've got to cut and paste this in, and then I've got these other styles, and oh, you had this font, and you use that, and that you get from Word. And again, your words express your thoughts, and for your thesis, your thoughts are what are important to us, not the layout. Let LaTeX. Okay, so some examples. So include files. So in LaTeX, we include content from other text files, and so we use things like this, which is /include. Right? Now this is a markup language, so this is not displayed, and this inc/structure is a text file that contains more text. So if we have a look at share LaTeX, we can go, if I go to my share LaTeX, and I might need to bring OBS, and right, so if I bring this across, right, so and you guys can't see any of that, so I'll make that bigger. Okay, so this not that big. Control minus it down. Right, that's a little bit better. And I'll just shimmy that closed, and I'll, yep, that's okay. So what we have here, and unfortunately for the stream, I don't know if we're streaming this properly, but I have up here I have document class, which in this class is the Bema class, right? So I say what kind of document I'm doing. I then have a bunch of use packages which says, hey, these are all the things that it needs to use to include. And then I do a new command, and so I do some input and some more use packages. And in this case, I have some Bema specific code here, which, and as you can see, like a computer program, I have these comments in here. So I've commented my code. They don't appear because they're comments, right? So you can actually discuss and comment about things. In here I say I have a notes page, which is plain, and I show notes on second screen equals write. So when I print my PDF, I get my slides and I get my notes here. Now in PimPress, when I'm displaying that, you have that, and I have my speaker notes. And if I press S, this is my view of my of this PowerPoint presentation, which isn't PowerPoint, it's PimPress, so PDF. So what I see is the current slide I'm showing you, which has this include, my notes slide, and my next slide. Right, so just like you would in PowerPoint, and it has, you know, elapsed time, which is going far too fast. So I flick back. Right. So for displaying my sheer LaTeX, this is what it kind of looks like. Now, when you first start using LaTeX, this can be intimidating. You say, well, where's my document, right? There's all this garbage stuff at the top. Where's what I'm actually saying on here? Where is it yet, right? And the answer, well, it's not there yet, right? Down here, I have use theme, style, vertical, language, English, IMT2681. That actually tells me that I'm using this blue bar down here, right? So I actually have, and I could change to IMT simple, vertical, or horizontal. Each of those is a different template. So if I, instead of saying vertical, I said, well, actually, I wanted the simple one, and I go recompile. So now all of this is happening in the cloud, it's online, and I can share it with other people. And then this one uses the simple IMT banner down here. Right, so that's been the change. And it's now completely, so it's changed the document, changed its layout, changed its format in the way that you might want to, right? So that's got the simple IMT there, where at the moment I have the blue vertical.
The stream is seeing the PowerPoint. I don't know if that's supposed to be.
Right, I think the stream is. Yeah, I need to. I would need to tell the stream to see this whole secondary screen. So I could try that. Let's see if I can fix my stream. So my stream, this one, I need to edit the window. I don't know if you guys have done any streaming, but what I need to do is find
display capture.
So not window, but display capture. So cancel and add display capture and display capture 2. Okay. Will it give me a choice? It gives me display 1, which is mine. Wait.
You already have a display capture on the other screen.
Oh. So changes discard. Discard. So display capture that one, which I can turn on. And I need to take...
If you move the bottom display capture to the top or up.
To just there.
There.
Right. Is that the right note? That's my page. So video capture device, display capture 2. Okay. No, it's not.
Okay.
I'm not able to find it. Well, I'll leave it and we'll just go back to talking to you guys. Right. So the stream is going to have to cope with
the software you're using for streaming?
OBS. So Open Broadcast Stream. So that's the streaming I'm using, and I'm going straight to my YouTube channel. So it's recording and streaming live currently, and it will record and put this up afterwards. Unfortunately, it will put it up with all of the standard discussion about how do we stream this, which is less professional than you might expect. So okay, so what we've got is there's all of that kind of stuff at the beginning. Most of that you guys don't actually have to worry about. We have in Share LaTeX a large amount of explanation of that. What you mostly do in LaTeX is start filling in the bits in the middle. So we encourage you to, instead of writing one big LaTeX document, separate it out into separate documents and use include to include those separate files. Now, I've got here an ink slash. This is a folder structure. So I actually explicitly use folder structures in my LaTeX system. So I have a repository, which is a folder, which has text in it and subfolders, and in those subfolders I have things like my figures and my pictures and my included source. Right? So I lay it all out so it's kind of professionally laid out in a kind of nice, understandable way. You can also do things like compile only parts of your document. If you get a really, really big document and you only want to see chapter 2, you just comment out all the other chapters and just view chapter 2. And it will lay it out and just show you chapter 2, right? So it's got that kind of power. You don't have to somehow extract it. LaTeX does images, but it takes efforts to get the images in. One of the things that Microsoft Word does really well is you can just grab an image and drag it in, and all the text moves around, and you can just lay it anywhere you like, and you kind of adjust a little bit and adjust a little bit and play with it, and spend lots of time getting your image exactly where you want it. And then you add one line above, and everything shifts, and everything changes, and then you have to go and play with it again to get it just right. And then you got a spelling error, so you add the S, and then everything shifts, and you have to go back to the image and play with the image, and yet you're wasting time, right? Don't play with the layout of your document. If LaTeX says this should be on a page by itself, let the image be on a page by itself. When you include images, you literally go include graphics. You do this. Include graphics. Here I've given it width is 0.2 of the text width. Right? So this is a bit of math here. And this is in my folder called figures, and it's called cart student, so map student, and that's that image. So to generate this image, that's the code that I've used. Right? And this is a PNG, so you just go include graphics, you tell it what to include, you wrap it in a figure. Now if you're writing your thesis, we don't want images just splayed around all over your document, because when you're working academically, if you have a figure, if you have a graphic, you should refer to it. And the only way you know where it is to refer to it is if it has a number. So you'll notice in academic work we go figure, number. If you don't put it in a figure, there's no way to refer to it. I can't refer to this because there's no number associated with it. And if I said, oh, the figure above, if LaTeX moves it to below, that reference is no longer true. Or see figure on this page. But if it's not on this page, then which one do you mean? So we, in academia, refer to figures by numbers, and then you have to have captions and labels. And so caption, and one of the things I talk to my students is, you see this? I've got the square bracket after caption. The square bracket is the short title that appears in my contents page, right? Because you know, have your list of figures at the beginning of a document? That's what appears at the list of figures at the beginning of the document. And here is what appears underneath the figure itself, right? So if we have a look on, I've got, yeah, so we've got an example plot here. What I found when I was doing this last night is that figure in the Bema format doesn't get a number because it doesn't understand, it doesn't have a table of contents that it's trying to generate. So it's a little bit harder, you have to refer to page number. But this is a figure. I have text here, and I'll have a short text which would appear in a table of contents. This is generated with GNU-plot, and it actually uses the math symbols from LaTeX to generate pretty numbers and pretty text in my figure, rather than the ugly things you get from Excel or directly from GNU-plot, right? So there are techniques and tricks, and I show them in our template file of how to get those kind of graphs. So if we just skip back again. Okay, so when I include graphics, you have a figure around it. Again, it's markup. If you don't put in this width information, it will do it at whatever size the image is at, which could be enormous and could be annoying. So yeah, so that's the way of including graphics. One of the other things we care about is including citations. So how many of you have been doing documents with citations? A few out there with document citations. How did you do the numbering or author referencing? So So who did number? So you did Mendeley, right? So you were using Mendeley, and it kind of, you set it at it, and it says like make it numbers, and it does numbers, and you say make it author date, it does author date. That's because it's kind of doing the LaTeX, dealing with that for you. EndNote for Word does that. You can also use Word's internal referencing thing, but it's, you know, it's a little bit trickier and it's a little bit temperamental. The beauty of BibTeX, in LaTeX, is that it uses a whole like BibTeX format. So there's these .bib files, and in a bib file you have information like this. So this would be a MISC. I have a tag which allows me to say, oh, I mean that one, right? And you have title, and it writes out the title. You can have author, you have year, and you can add in your URLs. Now, for larger BibTeX entries, you have much more information. This information is independent of the way it's laid out, right? You just give the give LaTeX, BibTeX, all of the information you have about the particular reference, and then your particular style will pull out the bits it needs to display in the way you've been told. So you don't have to go through and work out, oh, this needs this thing, this needs this thing, this needs this thing. Oh, we've changed format, so I'll need to go get these other pieces of information. No, so all the information in the BibTeX. And what's really nice is you guys can share those BibTeX files around because they're just information. And you can download them from Web of Science or from Google Scholar. Right, so if you use Google Scholar and you go on the sidebar on the side there, so if I go to here and we go, actually get over to here, here's my pointer, there it is, and I go Google Scholar, what you guys will find, what you can see is that if I go to Google Scholar and I make this slightly bigger, yay, Google Scholar, and what should I search for? Teaching LaTeX. So let's go teaching LaTeX, seeing that's what I'm doing currently. So here is a bunch of people on, yes. Okay, LaTeX. So outcomes of natural rubber LaTeX control programs on the Ontario Teaching Hospital. Okay, so that's a research paper. It's cited 122 times. So if I want to cite this, then I can, oh, they've changed the, I had noticed they've just changed it to being icons rather than words. When did they do that? I didn't, okay, that's new, I've not seen, oh, and now I can save it as well. This is new, obviously Google Scholar changed since last week. So I can click here and it will give me cite, and so it sees, like, so the MLA, you'd have this information, APA, you'd have all of this information, Chicago, you'd have all of this information, Harvard, you'd have all of this information differently, and Vancouver, you'd have all of this information. So each of these is slightly different in a different style and a different way, right? If you're doing that by hand, that's really annoying, really, really annoying. So what you do is you see down here, it's got, aha, actually want BibTeX. So you click on BibTeX, and it gives you, when I make that larger for you guys, just the information. How that information is displayed, in which order it's displayed, what additional information, all of that is just layout. This is what you need to know.
The library catalog also now exports to the...
So the library catalog will also export to this format, so you can just copy and paste this in. And if I wanted to cite this paper, which I'm not sure why I need LaTeX in a teaching hospital, but I can do one thing, I can do various things. I could save this as a .bib file and then include the entire file, or I can cut and paste it, I can copy and paste it in. So I can do copy, and I can go to my share LaTeX, wherever, oh, it's in the other tab. So I could just go up to my, get there, and go, now, I minimized it. This side has the, oh, it's generated a whole bunch of folders. Okay, I don't know why it's done that, but down here, I have this interesting wee file called example.bib. I go in here, it's got one, I enter there, I can paste that in, and now I'll have another referenceable paper. And in my sheer LaTeX, if I go in here and it's called that, you'll see at the bottom of the document, we'll just go down to the end. So all of this is available for you guys. It's up on the GitHub site for this, so you can download this whole talk in LaTeX, see how I've done all of this. Right? Down here I have so tools, just before tools we have, no, that's just, is it after tools? No, there's the printing references. In here I have some specifics. Proof theorem, there you see a citation on LaTeX 05. I could do, and also slash cite, because I'm doing a citation. And now you can see, so that was the 05. Taylor 2001 outcomes. That was the one I just added to the BibTeX document. And I can skip down and go, woot, I can add that in. And then when I compile it, it'll add that reference in, it'll add it everywhere. Right? So it adds appropriately to everything. And we can recompile and show that. Now, okay, so we have citations. Download in BibTeX. We've got BibTeX from the library, you've got BibTeX from Web of Science. You use the ID out of it. So this, like Askabel 9885, that's an ID. And I do cite that ID, and I get that cited in my document. I don't have to do any more. I don't have to give it a number. I don't have to say whether it's author date. I don't do any of those. I let LaTeX work it out. In the NTNU thesis, we support two types of referencing. There are only two that we support. We support Harvard style and Vancouver style. So Harvard style is for the interaction design masters because they like author date. Vancouver is numbering for the computer science grads. Now, if you have something different, we would have to add that in. But I actually have this boolean, which is Harvard citations false. If you change it to true, it'll change all your citation styles. If you leave it false, it gives you the numbers that we want for computer scientists. If you have it true, it will give you the author date that we like for interaction design. That's what a citation looks like. Just the data. You don't need more than the data. So charts. So I use GNU plot. In charts, graphs are just images, so you include them as images. If you want to do more exciting things, then we've got this PS tricks in LaTeX when you're doing GNU plot that allows you to do some really interesting graphs and make them look very pretty. And if you're going into our LaTeX document, you'll find that I show you in the master's thesis and the bachelor thesis how to use GNU plot to generate graphs on the fly from data. Because if you have a large number of graphs, you don't want to do them all manually, so you should be scripting this. You should be automating how you generate graphs. And that's one of the things that LaTeX is very good at. When I show you this graph, the lines in here are a picture. The numbers in here are actually directly LaTeX text. We also use a code listing package, and so you can get code listings. And there's a standard way of doing that. We wrap it in a figure, we use the listing package, and in our full colorized version, we actually show you this colorized. So if most of you, a lot of you will write code because we've got a lot of technical people here. So this is how you show your LaTeX, or show your computer code. This has Python formatting, so that's why it's bolded on Python words. There's also a version for C++ or C or any other language, right? Well, not almost any other language. One of the main reasons to use LaTeX, if you have maths anywhere in your thesis, LaTeX is probably the best way of doing that. In fact, if you've got a lot of maths, there's almost no other choice. You have to use LaTeX, because if you want to do this sort of thing, LaTeX is the only language that does it nicely. Right? So this is your standard, you're making a null hypothesis that your means are the equivalent. That's a fairly standard thing to be doing in your thesis. In the Bema code, you can see how I've done this, and you see how I've done this. What you do when you're using LaTeX is you search, you use, who uses Stack Overflow? Excellent. There is the same for LaTeX. LaTeX has a Stack Exchange site to help you with LaTeX. And there are a lot of really keen people who will answer questions. So if you do have questions, you can go there, and there are lots of questions already answered. And you get the same kind of effect of Stack Overflow, but for LaTeX. An annoyance in LaTeX, and if you've ever had to use LaTeX, tables are usually really annoying because they're very ugly. Because if you do tables in LaTeX, you have lots of ampersands and lots of layout information, and it's just, I don't know if you've used tables in LaTeX, it's just ugly. However, in the LaTeX template we give you guys, we have this CV Auto Book Tables, tabular, and I can read in from figure/age_IQ dot comma separated values. So I have a data file that has age, comma, IQ, 10, 100, 20, 100, 30, 150, 40, 100, 50, 100. And that's a data file. And when I compile my LaTeX code, it reads that data file and just places it nicely here. So if my data changes, then my document changes. So these numbers aren't embedded in my document, they're embedded in the data file themselves. Which means I can actually do another thing, which we do, which is, no, okay, not in here. I actually also have GNU plot in LaTeX, which will then look at the same file and display it as graph. So I change anything in my data file, it changes both the graph and the visual layout in the document, right? So I can automate all of that. And again, I've wrapped this in a table with a context. With the Bema format, you also have things like this, where you can lay out like nice, pretty theorems and proofs, with numberings and with citations. Now this hasn't got that additional citation added because I haven't recompiled and downloaded it. But there are ways of providing more information on your Bema slides. Right. So that's kind of the general stuff. Now I'm going to be very specific and have to go quite fast because I'm out of time. But you can get up and leave if you need to, because I know some of you have class at 1:15. Okay, so GitHub, HTTPS github.com copcse-ntnu. Okay, so if some of you are online, you can go there. This is the Community of Practice Computer Science Education. This was our kind of community GitHub site. It has the bachelor thesis template, it has the master's thesis template, it has the Bema template, it has a poster template. Right? So on there are the templates for all of this. You can, and the standard process is you go to GitHub, you fork one of these to being your own repository. You then go into Share LaTeX and tell Share LaTeX to import that GitHub repository. And it just imports it into your Share LaTeX. You can then work in Share LaTeX and anytime you like choose to synchronize back to your copy of the thesis. And then you have your thesis in GitHub and you can access it anywhere, and you have it in Share LaTeX and you can access it anywhere. Right? So fork and then import into Share LaTeX. At the moment, because I'm using the Share LaTeX for this, this Bema style I've just been editing and added that citation to, and so what I can do is I go to menu and I go GitHub, and it says, there are no new commits on GitHub since I last looked at it, so I don't need to pull things in. But I can push my changes to GitHub and I say, okay, I'll do that. And because we're version control, it says, what's your comment? And I can say, post presentation, and go commit. And that is now syncing it onto the website you guys can look at. Right? So if you're on the website, it will have just updated NTNU Bema theme NTNU. And it will say like committed 1 second ago on the website if you refresh the website. And you'll get all of the changes that I've made up until this point. Right? So that's a way of sharing what you do as well. So that's where we have things, that's where we have the template. In both the bachelor template and the thesis template, I try and show you how to do a bunch of things, right? I try and make it informative. So don't just kind of copy it, delete all the content out of it and start filling in your own. Read some of that, it shows you how to do some stuff, right? The Bema, I did this in Bema so you could see how to do the stuff if you want to do a presentation in Bema. If you're computer science and I think interaction design, and we're moving to using an online system called Dame. Dame, yes. Dame versus non-Dame. Bachelors don't use Dame, master students use Dame. Right? So NTNU master students submit in Dame, where you go and you fill a whole bunch of information on the web, and then you upload your internal content, which is just the PDF of everything but the front material. Your bachelor students don't have that, so we have in your template there's a thesis data. You fill in all of that in a document called thesisdata.tech. You put all your stuff in there, and that's the same deal. For master students, I have a damedata.tech file. You fill in all your stuff there, and then you can either generate in a Dame one, which is just the internal document, or your whole with title, page, and cover. Right? So you've got choices in how you display your thesis. And in that beginning of the templates, you'll find where your thesis name is. Pick your thesis name. It'll give you the institute. It'll give you the name of your degree. It'll resolve all of that. We also use a few macros, and macros are short ways of saying things. So CPP, laying out C++ to make it look like C++, is like a whole line worth of code. But if you go /CPP, you get C++. I use a lot of the to-dos and the /com. To-do is turned up in green, bright green in the document. So you can say, oh, that's something left to do. And comments are what I use as a supervisor when I go into my student theses and I want to write a text-based comment in the thesis. I'll go /com and I'll write a comment. Right? So I can put comments in directly and they can see them because they show up in bright red. Because you know that's what your markers comments should be in. Right? So bright red, bright green for these two. You can see how those are done in the document itself. So as I said, the Dame data text, generating a PDF, we have Max, so this will be a Master of Applied Computer Science. In English, you have options of English, Norsk, and Nynorsk. So if you are writing in Nynorsk, we do have the Nynorsk option, which will change all of your contents headers and things into Nynorsk. You still have to write your document in Nynorsk, so it won't do a Google Translate of all of your words in English. But at least it gives the contents page in Nynorsk, and the abstract is the Nynorsk version of those, right? So you have got those three. And we use NTNU thesis /NTNU thesis. We don't currently have the pretty B5 cover page that the Dame system creates for you. We just have a straight cover page, right? So you can see what it does. If any of you are really pushing for us to do a B5 cover page, then maybe we can work out how to do that. And we don't have the pretty image that you get from the Dame system that you can put on your front page if you want. But then, you know, you're not having to go through their system if you don't want to. Right, so the tools that I use and that you should look up and be aware of. Share LaTeX. You should all try it, even if you choose to edit offline and on your own. I use Technic Center on mine, but you can use TechShop. Mac have a whole bunch of systems. So Share LaTeX is nice. You don't need to install anything. It's just a web page. Jabref handles all of my bibliography database, so that takes that text file, gives me a GUI to enter and edit it. Really nice. You should download that. Web of Knowledge. If you've not talked to the library about Web of Knowledge, you should go to Web of Knowledge and see how to cite and like look at research papers. You can tick them to get abstracts down, to get the whole bib citation. And the trick that I use, tick the include abstracts. Because what's really nice in your bib file is to not have to answer the phone. Go away. Right. So what's really nice is if you have your abstract in with your bib information, when you're trying to cite a paper, you can do a word search, and if the word appears in the abstract, you'll find the exact citation because you've got the abstract with it. Right? So it's not just a file that looks, it's not just something that looks like there. not just this, you can actually have abstract equals and then just have a lot of text that's the abstract. Right? You also can go note, and you can write your own notes next to it, right? Which is really nice. So the tools that I use are there. I use GNU-plot. If you don't know GNU-plot, it's a great way of mapping things, but that's its own lecture on how to do really nice graphs and scriptable graphs. Doxygen for code commenting has a LaTeX output, so you can output all your comments and add them as all your documentation as an appendix to your thesis, nicely in LaTeX. The /new command, this is very useful once you're using LaTeX to say, oh, I do something a lot, I write this a lot, I can make a command of it, right? So it makes it much simpler. So I did that a lot with my thesis because I had a lot of mathematical terms that I'd keep having to write. So I just make a wee command like /C++ and use that. If you're programmers, because LaTeX just text, you guys can write your own output, which is valid LaTeX. So if you wanted to, you could make your program generate LaTeX output, because it's just a text file, nothing clever about it. So you can actually make your program, when it writes its data out, it writes it in LaTeX format, so you can just include your data directly into your thesis, because it's already been laid out properly. And for this presentation, I used PimPress, which is a presentation tool for PDF presentations, and it works nicely with LaTeX because LaTeX generates PDFs rather than generating PowerPoint slides and things like that. Right? So I've done this all in LaTeX. So all of this was in LaTeX. This is in a PDF viewer, and I'm actually about 15 minutes over, but that was and this is the reference. That's what it looks like in the standard referencing style for this document. If I recreate my document and I added that additional citation, I can flick over and show you what that will look like. If I go close and we go recompile and I minimize that. So we recompiled down the bottom here, right at the end. I should have had another one. Why is it not giving me a second one? Recompile, there you. Fingers crossed that I got this right. What does it do?
Well, it's refreshing.
It's going.
Something's refreshing. Yes! See, it did work. I got a second one. It's always a problem to live edit things, and you go, "Oh, where did it go?" But yeah, so this would now be live in here. This is if I was using a note page. That's why it's got this blank on the right. Okay, so with that, I'll stop talking and I'll ask for questions. And so, thank you. Right, so if I go to Share LaTeX, I can also show you that in here, if I go up, you see that I have a bunch of LaTeX documents, including an NTNU master's thesis. So who wants to see the master's thesis? Who wants to see the bachelor thesis? Bachelor theses? Okay, so if you guys go online, you'll get to the bachelor thesis NTNU. So this is so if you clone the repo and you upload the repo from the GitHub site, that GitHub.csd NTNU, you will get this thing. And you can see I have cover page, images, include NTNU thesis. This is the stuff you don't change. You can change that in here and here and in here. This has called bachelor example. You can change the names of these if you like. That's up to you. But if we have a look at the bachelor thesis standard here, this bachelor example.tech is kind of the header file which does all of this layout and setup. I have dark colorations and I define a whole bunch of things. There's my C++ new command, which is crazy. And so you can see all of this Here is com color red, to do color green. If you want to change colors, you can just type in the other colors in here. Right? So it's not secret and hidden. I don't like having to type NTNU eYervik all the time, so I made a new command /GJ, which just types out NTNU Yervik for me anytime I need to do that. So that's an example. It shows you how to do the strange Norwegian characters. And then here, it does the make front pages, which is actually makes all the front material for you. I include a preface as an input, and then a table of contents, list of figures, list of tables, lists of listings. So if you've got code listings, it's a list of listings, and it's actually LST, which is short for list. So it's list of listings. And then I input introduction, requirements, technical, process, implementation, development, testing, discussion, and conclusion. Each of those is in here, right? So when I go and have a look in my actual include file, I can see that I have each of those things in here. And if I have a look at the first one, introduction, I can go to there, and it does simply /chapter introduction. So instead of having all that layout and all that kind of crazy stuff of LaTeX at the beginning, this is now where I actually write. This is where I do my work. And so you do /chapter, /label tells me a way I can refer to this. So I don't say chapter 1, I say /ref, that name. And this is now just text. And I have a new section, /section, with the thing in quotes. And here's a subsection for writing. And so yeah, that's what it looks like to actually work in LaTeX, is you do this sort of writing, but you do it in its own separate file away from all that garbage header information. Right? So, and if we go back to the template, so I include all of those. I include the bibliographical style and the... Now, with the bibliography, I can include as many files as I like. I can actually have like 10 bibliography files, each of them with their own references. So I could have like an NT, I could have an AI one, I could have a graphics one, I can do anything I like there. And you know, I've also got like including meeting logs as an appendix, so you can do those sorts of things. All right, so if you download this, there is a lot of information. I show you how to do a lot of things in like implementation in here. You can see this is some code listing example in language C++. I show you an example in Python. There is lots of, and so those are code listing examples. If I go into results, I think I put it in results. Technical. Maybe it's in technical. I put so requirements. There's some maths. So I've put figures in here. So here is an example figure. Here is another example figure of including graphics. And there is including my table manually, and then I show you how to do it using book tables, which is this one. And then further down I have how to do quotes, and how to do lists, and how to enumerate, and then how to do description lists. So I take you through and show you how to do all of these things, right? So combining the sheer LaTeX 30-minute lessons with the stuff that's already in here should give you most of what you need to write your thesis in LaTeX. Okay? So, questions?
Well, thank you so much for coming. Do you have I'm going to just say goodbye, but you can ask him questions afterwards if you like. But thank you all for coming. I hope it was useful. It was for me anyway. I learned a lot about LaTeX. And if you have any questions, please do refer them to Simon, because I obviously have no no real plan for supporting LaTeX at the moment. But I'd like to give an extra applause to Simon too. What a wonderful lecture this was, all over the place. Thank you.
So I can probably stop the stream if you want me to. So I'll then go here and try and stop streaming.